Okay, welcome back. Lesson 17, multiply and divide fractions. When you are multiplying and dividing fractions, you do not need a least common denominator. When you're multiplying and dividing fractions, just remind yourself you don't need a least common denominator. So let's start off with operation multiplication. So if you have A over B times C over D, it's perfectly legal to just sort of travel straight across and the numerators and the denominators and say AC over BD. If you need a numerical example of that, think about this. 2/3 times 5/7. All right, according to this, it's perfectly legal to go straight across and say, gee, that's 10 over 21. And then you would take your final answer, 10 over 21, and reduce it if possible, but 10 over 21 is simplified, is reduced. So yes, so when you're multiplying fractions, you just travel straight across like that, and life is good. Now, if you're a person that has memories of like cross-cancellation and things, cross-cancellation is not always applicable, right? It's certainly not applicable here. So safest thing, travel straight across and reduce it at the end. Okay? Little note on the word of that triggers you for multiplication. If you say half of 3/4 is 3/8, that translates to 1/2 times 3/4 is 3/8. So we can translate the word of to mean multiply and the word is to mean equals, which is going to be really important when we do word problems. Let's try over here. Okay, so 1/8 of meaning multiply, 2/16. Now we can put 2/16 over 1. Is means equals. Now, according to what we said, you travel straight across, right? So you'd have 2/16 over 8, which is right, but you say maybe it can be simplified, right? Maybe 8 goes into 2/16 evenly, so we check that out. 8 goes into 21 about twice, and 21 minus 16, what, 5? Sorry, this pen's being fussy. 16, draw the line and subtract. 5, bring down the 6. 8 into 56 goes 7. So aha, 8 goes into 2/16 evenly, in fact 27 times. So you do kind of explore that. Okay. Let's take a look at this next fact, and we had already mentioned it before. Fact, if A, B, C, D are numbers and B and D are not 0, because of course division by 0 is undefined, then like we said earlier, A over B times C over D is just AC over BD. In other words, to multiply two fractions, you just multiply the numerators and multiply the denominators. So we'll just try one more of those. So if you have 3/8 and you want to multiply that with, let's say, 4/5, you travel straight across and you say 12 over 40, and that's great. I always say if you put that on a test, I'm happy. It's just that it's not reduced. It's right, it's just not reduced. So then you say, okay, well, maybe I can find a number, a common divisor. We've talked about reduction in the past. So, 12 over 40, I can divide the top by 4. I can divide the bottom by 4, that common factor that they have. And you're going to get 3 over 10. 3/10. Voila. Okay, so multiplication isn't that bad. What about cross-cancellation, you say? Because like I said, a lot of people have memories of cross-cancellation somewhere in their past. Well, try it. You might like it. So let's talk about what's legal. It's legal to cross-cancel on the diagonals. It's also legal to cancel, up and down. You just can't cancel laterally, like from denominator to denominator. So I can say 5 goes into itself once, and 5 goes into 15 3 times. And I can say 2 goes into itself once, and 2 goes into 16 8 times. Now, once you perform your cross-cancellation, now you just gather straight across, gather what you're left with, meaning 1 times 3. You can even write that out if you want. And downstairs you've got a 1 and an 8, so 1 times 8. Okay, so we're left with 3/8. Now see, stylistically, let's talk about, the thing about cross cancellation is people get lost in the land of their own handwriting. So what I'm saying is, maybe you're a person that would rather just travel straight across and reduce it at the end. So bear in mind, little note to self, you don't have to cross cancel. You know, if I would have traveled straight across, 2 times 15 would have been 30, and 5 times 16 would have been 80, and hey, 30 out of 80 is easy to reduce back down to 3/8, you know what I mean? So cross cancellation isn't always necessary. Now, but I'm going to play this. If you have a whole gigantic string of multiplication like this, if you go straight across, you're going to get gigantic number over gigantic number and stuck reducing it. So sometimes we're sort of forced to cross cancel. So let's hope you follow me. Maybe hit pause, try it on your own first. Okay, ready? 3 goes into itself once. 3 goes into 9 3 times. Now you can use, now let's look at 4. 4 goes into itself once. You can use this 4 on this 8. 4 goes into 8 twice. You cannot cancel laterally. I can't use the 5 on the 20. I cannot do that. But I'm going to continue. You can jump cancel, like I can use this 3 on this 18. So, oh gee, 3 goes into itself once, and 3 goes into 18 6 times. See that? So you want to try and create ones, is what I'm saying, the best you can. Like, I can use this 2 on this 16, right? 2 goes into itself once. 2 goes into 16 8 times. So you kind of have to look on the diagonals, see what you can use. Now clearly, you know, 5 has no relationship with 8, and I can't use the 5 on the 20. You can't. That's illegal. So at that point, the only thing I can do, I see 8 and I see 20. And I know that 8 and 20 have a common factor, but at that point I'm going to leave that alone and just travel straight across. So I'll deal with that later. So 1 times 1 times 1 times 8 times 1, that makes 8. And downstairs, 1 times 1 times 5 times 20. And I've also got this 6 here as well, so it's gathering all the things that you're left with. So 5 times 20 is 100, times 6 is 600. So after all that sweat equity, you arrive here, but it's still not quite reduced. So you say, okay, there's a common factor. And you say, I'm going to try and divide by 4, right? So if we divide that by 4, divide that by 4, okay, then we're going to have 2 over. And sometimes, if you're not using a calculator, you might have to go off into margin and figure on that. 4 into 20 goes 5. So 150. So after all that, you arrive at 2 over 150. And hey, gee, those are still even numbers. So 2 goes into itself once, and 2 goes into 150. What, 75 times? Whew. So that took a while, you know, to get it into that final reduced form. But I wanted to show you something cute. Although it's not a calculator course, this is something to sort of test yourself with. Check this out. So this is not a calculator course, you know, we're testing our ability to do these things by hand. But, you know, when it's midnight and you want to crutch and you want to know that you did it right, check out, we could type this whole string of multiplication of fractions that we had in the beginning and double check our answer. So check this out, 1/3 times 9/8. Notice how you type in fractions into a TI-83 or something like this, you know, chunk them off with parentheses, times 4/5. So I'm typing in all those original fractions that we had. 16/20. That's why people get hooked on the calculator, because it makes it easier. And then 1/18. So you key all that into the calculator, you hit enter, and it gives you that, which is a decimal. But then you hit math, frac, enter, just hit enter. Look at that, and voila, 1/75. So, you know, and that's exactly what we got. Right? So we have the ability to check these things on a calculator, but just test yourself on your cross cancellation skills, I would say. Okay, once you've done your cross canceling, if you goof up along the way, you'll probably never find it. So, you know, it's really hard to look back at it because you see all these things canceled out. So you might just want to scratch it and start again if you feel like you goofed. That's just a test-taking strategy. Okay, reminder on exponential expressions where the base is a fraction. When in doubt, expand it out. So reminder, if you have 2/3 cubed, it really means 2/3 times 2/3 times 2/3, which we now know we can travel straight across and arrive at 8/27. So let's play that again. With this example, 3/5 cubed, well, now we know that means 3/5 times 3/5 times 3/5. Well, that's good. Those numbers are going to grow quickly. So 3 times 3 times 3 makes 27. Times each other. Like 3 times 3 is 9, times another 3 makes 27. 5 times 5 is 25, times another 5 makes 125. So just when in doubt, expand it out, is what I would say. Okay. The next slide, as a reminder on reciprocals. Little reminder on reciprocals. Two numbers are reciprocals of each other if their product is 1. So, A over B, we call B over A its reciprocal. And notice, if you take A over B times B over A, you're going to get AB over AB, which is 1. So let's just kind of make sure we're understanding this little fact. Are 7/8 and 8/7 reciprocals? And we say, yeah, sure they are. But let's check. Is it true that 7/8 times 8/7 equals 1? Well, yeah, because 7 times 8 is 56. Either way, you're going to get 56 over 56, which is 1. Okay? So indeed, they are reciprocals. Every number has a reciprocal except 0. The number 0 has no reciprocal. Why? Because there is no number that when you multiply it by 0, the result shall be 1. Right? Like a number times its reciprocal has to make 1. And if you multiply something times 0, it'll never make 1. It'll be 0. So every number has a reciprocal except 0. That's just a note to self. All right, now let's take a look at division. Division is very closely related to multiplication. Division can be rewritten as multiplication by the reciprocal. So what I'm getting at is if you have A over B divided by C over D, you always take the time to do a rewrite and call it A over B times D over C. And notice that I use the reciprocal of this original fraction. Okay, so if you need numbers, 3/5 divided by 2/7 can be rewritten as 3/5 times 7/2. And then when you rewrite it, then you multiply. So 3 times 7, 21. 5 times 2, 10. 21 over 10. So let's just try an example together within these notes. So if you have 12/7 and you want to multiply that by 8 over 21, I'm sorry, divide. I meant divide. You want to divide that by 8 over 21. You would rewrite that as 12/7 times the reciprocal, 21 over 8. And then, like I said, if you're real comfortable with cross cancellation, do it. Otherwise, don't do it. Travel straight across and reduce at the end. But here, 7 goes into itself once. 7 goes into 21 3 times. 12 and 8 have common factors, but I'm going to dodge that, just because I like to do that later. 12 times 3 is 36. Clearly 1 times 8 is 8, meaning I like to reduce at the end. I know that 36 over 8 reduces, common factor of 4. So note to self, divide by 4, divide by 4. So we're going to have 9, and 8 divided by 4 is 2, so 9/2. And again, although this is not a calculator course, what I like to do when I'm at home and I'm just, want to feel confident in my answer, I'll be like, I'll do it and then I'll check it. So I'll be like 12/7, and then I'll hit divided by, 8/21, get a decimal, and then hit math frac. 9/2. Voila, 9/2. But only touch the calculator after you've tried it by hand. Okay, and I believe this is our final slide for today is evaluation of expressions. We're gearing ourselves up for doing order of operations on So let's dive in. If x is 5/6 and y is 2/5 and we have to evaluate x divided by y, we know that's a lot of plug and chug, right? So we know we need 5/6 divided by 2/5, and now we know that that really means 5/6 times reciprocal, right? Times 5/2, which really, and then travel straight across, which really means 25/12. And voila. Sorry, the pen was being fussy there. 25/12, you see I've snipped in the answer. So we're able to perform division. Now we can actually perform a lot of things. This is a good one. Maybe you want to hit pause and try this one on your own, but plug and chug. So now we have a half squared times your y guy, which is 3/5, plug and chug in 3/5, divided by 2/25. That's phase one, is writing it out. Then clean. A half squared really means a half times a half, which is a fourth. Now if you need to, I always say if you need to think about that off in the margin, let me do that in another color. Think about that off in the margin somewhere. A half squared means a half times a half, which is a fourth. Okay, so we have a fourth. Now I'm going to come back here. Times 3/5. And then, aha, division really means multiply by the reciprocal. So I'll just use the reciprocal of that, which is 25/2. Now, that's a good thing. Now we have a whole string of multiplication. We can look on the diagonals for cross cancellation. 5 goes into itself once. 5 goes into 25 5 times. And now travel straight across. 1 times 3 times 5 makes 15. And downstairs, 4 times 1 times 2 makes 8. So 15/8. And voila, we got it. So maybe you tried that on your own and got 15/8 as well. So like I said, we're gearing up to do order of operations on fractions, but my next video involves the rules for addition and subtraction, and then we'll be able to put it all together in one lovely dance. So hope that helped. Good luck.